Hi, friends. Welcome back to the Regenerative Agriculture Podcast, where we have all kinds of fun conversations related to agronomy, managing plants and crops and livestock, and ultimately having an impact on human health. Once in a while, you have an experience that really makes your day, makes your week, makes your month. I had one of those back in the beginning of December. I attended an event in Minnesota, and someone who I'd never met walked up to me and said, "Hey, you don't know me. You don't know who I am. You don't know what I've been up to, but I've been testing your BioCoat Gold for the last couple of years, and here's all my data." And it felt like somebody handing me a check for $10,000. So that individual is Joe Ailts, who's here with me today. Joe, thank you very much for all the things that you have been bringing forward. I've been, first of all, the data that you shared and the stuff that you've been working on with BioCoat Gold kind of raised my eyebrows a little bit and brought a big smile to my face. So thank you for doing that. But um, you've you're doing a number of different things and have a lot of interests related to agronomy and agriculture. Tell us a little bit about your story and the scope of the stuff that you're working on and what you're excited about.
Happy to do so, John, and thank you so much for the invite onto the podcast here. So I like to say that I was born with a green thumb, a competitive spirit, and an insatiable curiosity. And it stems back to my childhood. My parents had me when they were teenagers. And as such, I spent a lot of time with my great grandmother, who had the most amazing vegetable and flower gardens imaginable. So in my formative years, following my great grandmother around the garden is where the green thumb came from. Um, about the time that I graduated high school, was moving into college, I developed this interest in competitive giant pumpkin growing. And it's a really interesting, fascinating little niche of the world where we're trying to grow these giant pumpkins to now over 3,000 pounds. And so that really,
Joe,
go ahead.
the two groups of people who, as a group, who I talk with, actually, I'll expand it to three. The three groups of people who know more about plant physiology than almost anyone else I talk to are the giant pumpkin growers, the cannabis growers, and the wine grape growers. Those three groups obsess about understanding plants and plant physiology, unlike most agronomists I know.
100%. Yeah, it's been quite the ride with these competitive giant pumpkin growers. We're absolutely going all in on everything we do. And then the insatiable curiosity, I think, is really tied to that competitive spirit. In that giant pumpkin world, we are trying to look under every rock, overturn every leaf for every possible advantage we can in pursuit of this 3,000-pound pumpkin. So you put all those things in a blender, and what you get is an individual who is absolutely passionate about soil health and agronomy, especially in row crop systems, where I spend most of my time during the day as an independent consultant. But then on evenings, weekends, and holidays, it's doing the work in the giant pumpkin patch here at home on our little 3-acre hobby farm, is also growing regenerative sweet corn and pumpkins for market sale at the end of our driveway. So lots of fun here in Northwest Wisconsin.
Yeah, I was just about to ask that. So you're in Northwest Wisconsin, which is it's pretty far north to be growing giant pumpkins competitively. I'm sure you're covering them up in the spring and getting them started really early. What are the weights that you've been able to achieve that far north?
Sure. So we live right on the 45th parallel. So we are literally on the north side of halfway to the North Pole. Our growing season is really condensed up here, and we have to use a lot of structures to help preserve heat early on in the season and, of course, on the back end of the season. Me personally, I've grown a pumpkin that weighs over 1,420 pounds, which may sound respectable at the outset. But when you compare that to what the folks at the very top echelon of this hobby are doing, pushing the 3,000-pound barrier, not even halfway. But nature continues to humble us with her ability to put together a fruit that can grow that large in such a small space.
Would it be a good guess or a good assumption that the growers who are pushing the 3,000 pound limit are quite a bit further south than you are consistently?
So interestingly, most of the competitive giant fruit at the top of the record scale fall right on the 45th parallel. There's something unique about that number. Again, being halfway between the equator and the North Pole, I think it strikes the perfect balance between day length and optimal temperature ranges. And so one could conceivably assume that if you further south and longer growing season, more heat, you might be able to produce a bigger pumpkin. But unfortunately, that's not what the data shows, actually. I think we strive to get as much sunlight as we possibly can. They prefer moderate temperatures in the 75 to 85-degree range. Once we get outside those boundaries, you start to see things drop off precipitously.
Intriguing. So the in addition to the giant pumpkins, you're also doing sweet corn at home. But then tell us a bit about the scope of your agronomy work.
Sure. So I work mostly with row crop farmers here in Northwest Wisconsin, where primarily it's corn and soybeans with some dairy forages thrown into the mix, a few small grains, and I even do some work with North America's largest horseradish producer as well, which is based in Eau Claire, Wisconsin. So it's a really unique lineup of crops that I have the opportunity to work with. And my goal in my independent agronomy work is meeting farmers where they're at. So I work with a number of farmers who are much further down the regenerative spectrum, where cover crops and no-tills were things that were tried 10, 15, 20 years ago, but also work with a fair number of farmers where they're just starting to dip their toe in the water into incorporating more soil health into the way they operate. It's a unique challenge here in Northwest Wisconsin because, as you had mentioned, we're right on the northern boundary line of what we call the Corn Belt. And so 30-minute drive north for me, and I am in what they call the Northwoods of Wisconsin that is nothing but trees and lake homes. So we do farm on the fringes up here. And my personal experience shows that if we can do cover crops and no-till in this part of the world, they really should be able to do them just about anywhere else you get meaningful amounts of rainfall. And it's a lot of fun working on the fringes up here because there's a lot of unique challenges with that. But I'm also encouraged by how successful the farmers who do these types of soil health practices up here have been in their attempts to incorporate these practices.
I think there's some farmers further north of you in Canada that would like to have a conversation.
And I'm happy to do so. I'm sure there's much to learn there.
Yeah. Yeah. So in the one of the pieces that you and I spoke about before we hit the recording button was some of your work on mycorrhizal fungi and some of the things that you studied with mycorrhizae. Um, I had this experience yesterday. I was visiting a citrus operation that we work with, and this operation is doing many things well. But I observed something that I don't remember seeing before quite to this degree, and that was a soil that did not hold on to calcium. Very sandy soils with consistently high annual limestone applications, and the limestone is not sticking around. It's obviously a semi-tropical environment, a high rainfall environment, and the limestone is solubilizing, and then it's leaching, it's disappearing. And I never thought of calcium as being particularly leachable. But when you look at the soil profile, look at what's happening, you look at the history and the context. A little while ago, I interviewed Benny McLean here on the podcast, and more recently, I interviewed Herb Young. And the one thing that became clear to me from looking at this operation, they are working hard towards making a shift, but this soil no longer has the fungal population and the organic matter to hold on to nutrients, including calcium, and calcium is just flushing through the system. So I've been so fascinated by this, by fungi in general and mycorrhizal fungi in particular that have the capacity to aggregate soil and turn soil into, in many ways, it is fungi that are fueled by plants that convert decomposed rock particles into soil. And so I've always been fascinated by this. I know you have as well. Tell us a bit about your work with mycorrhizae.
Sure. I just think they're one of the most incredible species on the planet, and certainly one of the most important in the soil profile. So the giant pumpkin growers have been using mycorrhizal fungi as an inoculant in their systems for over 20 years. And so my history with them traces all the way back to the first time I grew a pumpkin, and a little bit of background there on why that is so important. As a vine crop, as you know, they grow across the ground, and everywhere that a leaf grows up, an adventitious root grows down into the soil. So in a competitive giant pumpkin patch, which is typically about 1,000 square feet in size, you may have over 1,000 leaves that are covering that leaf surface area. So everywhere leaf that goes up, if there's an adventitious root grows down, that means there's potentially 1,000 more root systems that can get into the soil profile and start to mine that for water and nutrients and everything else they grab. The giant pumpkin growers were literally spoon feed, and I say that quite literally. We will spoon feed mycorrhizae at every one of those leaf junctions to encourage adventitious rooting colonization of mycorrhiza. It is for this reason that I believe we've been able to take weights from 1,000 pounds to almost 3,000 pounds in this competitive hobby. And so how do we take those experiences now and move them into row crop production? I think the potential is there to have similar types of outcomes. And so that's where my inspiration for taking this out of the pumpkin niche into the row crop niche was really inspired by.
When you literally spoon feed, is it necessary that it be a tablespoon or is a teaspoon okay?
Yeah, either one. We don't really know how much is necessary. The point is if we can get it out there, we let nature decide how much is necessary. And because of that, it's not impossible to see 40 or 50 pounds of growth overnight in a giant pumpkin that's really maximizing its size potential.
So talk about this just a little bit because mycorrhizal colonization is this interesting thing. Um, and you would think if you had a pumpkin plant with a large root system that was colonized by mycorrhizae, and you would have an adventitious root moving into the soil, you would think that that adventitious root would naturally become colonized by mycorrhizal fungi in a matter of a couple of weeks. Um, so is that not the case, or is that too slow? Are you just speeding up what happens naturally? What are the advantages that you're gaining?
Those are great questions. My experience in this competitive giant pumpkin world is that these growers are not going to leave any potential pounds on the table, and as such, are going to inoculate every adventitious root system, even if they're already punching into an established mycorrhizal network. Again, it's not about cost. It's not about what ifs. It's about ensuring that every single root is inoculated by the time it gets into the soil profile. And so that really begs the question is, how do we take a system like that is incredibly intensively managed without any consideration for cost and now translate it into row crop potential? And adapting that system has been the real challenge, but I feel like there's now been some signals that I've been able to observe that give us reason to believe that this can be done profitably as well as agronomically.
Yeah, when you use the phrase with no consideration for cost and row crops in the same sentence, it gives lots of people pause.
Certainly does, and I understand why. It certainly does.
Yeah. So what have you been doing in row crops? What have you been experimenting with, and what have you been
Sure.
observing?
So I think you've shared some really great information in regards to how do we get the most out of biological inoculants. And I believe in the past you've made, and I'm paraphrasing here, the phrase that seed treatments are probably the most lucrative, agronomically and economically advantageous way for us to incorporate various types of biologicals into row crop systems.
That's a
My
good one.
experience has shown that that is indeed the case. And so when you take a dry mycorrhizal inoculant and you coat that onto a corn seed or a soybean seed, I believe we then have the setup that can create colonization in the furrow right out of the gate that allows then the establishment of mycorrhizal networks that can potentially go to work and help these plants do a better job in their productivity. That's what my research has been able to show. So for the last couple of years, I've established in-field research where we're using large-scale blocks in order to achieve this. We're talking 12 or 16 rows, split planter, minimum 600 or 700 feet of row length at the smallest size, with many of these being split planters at field scale. One particular circumstance I can highlight is a 160-acre field that had a 40-acre block where we saw a 17 bushel response as a result of inoculating corn seed with Biocoal Gold. That was really quite stunning. Now, a little bit more nuance on why that response was so significant. This was on corn following horseradish, and the astute observer will recognize that brassicas don't colonize mycorrhiza. So if you follow
Supposedly.
supposedly, sure, there's caveats there. I understand that. Generally speaking, though, if the degree of colonization in a brassica like horseradish isn't as robust as other types of grasses or legumes, then the assumption is coming back in with a mycorrhizal inoculant in an environment that had been heavily tilled, that had a primarily brassica for not just a growing season, but actually 18 months because horseradish is a 2-year crop growing cycle. The assumption is that perhaps there would be a positive response by putting mycorrhiza in the system. And then, taking that to yield, we did see a 16.9 bushel response where the corn that was treated with Biocoat Gold certainly stepped above the non-treated areas of the field.
One of the criticisms that I've heard leveled at the use of mycorrhizal fungi inoculants, perhaps more so than others, and this is now years old. We've had so much success in the field that this criticism has kind of vanished. But the critique was actually originated from not from farmers and growers, but from people in academia who were studying mycorrhizal fungi. And the point that they kept making is that uh, you don't need mycorrhizae on the seed. You need mycorrhizae below the seed to intercept the root system. But of course, when you look at it from a practical application perspective, delivering it on the seed is the one thing that you can do relatively easily and consistently and inexpensively. And so that becomes the kind of the default delivery mechanism because that's what's logistically feasible.
100% agree. However, in doing so, I think that tees up other questions and concerns that we need to be able to work our way through in order for this to prove itself out. Again, the astute observer here will go, well, wait a minute. If you're planting standard, conventional corn and soybean seed, most of this stuff is treated with fungicides, and
Exactly.
that's the way it's coming from the factory. That's what we have to deal with. So, the question is, if you're going to put a mycorrhizal inoculant on a seed that already has a number of different fungicides meant to kill these organisms, what are we even doing? Well, that question occurred to me a couple of years back. So I sent fungicide treated seed from a major brand, both corn and beans, to a laboratory. I asked them to inoculate with their mycorrhizal fungi, and I said, please grow these out and tell me whether or not the mycorrhiza colonize in the presence of this fungicide. And lo and behold, the researcher there sent me back beautiful photos of roots that had been aggressively colonized by mycorrhizal inoculants, which gave me a huge sense of relief that we had not reached a barrier where we can't do this because of the way that our system is set up to operate. So I have data based on the research that I have conducted that suggests we can coat fungicide treated seeds with mycorrhiza and still get meaningful colonization out of those roots. When I couple that with the data that I had shared with you at that Minnesota event, I think it's proof of principle that even though we have these fungicides on these seeds, there is still the opportunity to colonize mycorrhiza meaningfully.
Yeah, it's thank you for sharing that. That's interesting data, and I'd love to take a look at that. And I'd love to share those photos with our audience. If you could share those with us, I'd love to share those on social media and with the link here. But um, I've had that same question many times as well, and we haven't had the data that you have, but just experientially, we put this product on treated seed, and we get some very noticeable and very worthwhile crop responses. And so that raises the question: as all right, are these fungicides not having the impact on mycorrhizal fungi that we thought? Are they not effective on spores while they're in the spore form? Like, what exactly is going on? What exactly is happening here? And I also know that or I shouldn't say that I know. I have this. I'm speculating here, but I'm speculating that there are some of the organisms in BioCoat Gold, bacterial organisms that are quite effective at remediating hydrocarbons that might be making the fungicides a lot less effective. But I don't know that to be the case.
These are great questions to ask. I have the same ones that are kicked around in my head. Don't know if I have the answers as to why it works, but it does. Maybe we just overwhelm the system with so many spores. It's purely a numbers game. The fungicide can take out or slow down the colonization of some of them, but it can't get them all. Uh, I've been able to further corroborate the success of this system by measuring mycorrhizal colonization to some degree with the PLFA test in season. And so in that particular field I'd mentioned a moment ago of horseradish, that was a 40-acre block size, I went out in season, midway through the season, and I took soil samples of the corn that had been treated as well as the corn that had not been treated, sent those off to the lab and measured the PLFA test, which is a proxy for mycorrhizal colonization. And I found that there was 20% higher levels of PLFA in the treated zone. And so while we may not understand the degree to which these fungicides have an impact on colonization of mycorrhiza that's on the seed, we have had some data on the back end showing that there is more aggressive mycorrhizal establishment when you treat them and measure in season.
Yeah. So you mentioned this one field that had, following the horseradish, that had a 17 bushel yield response. What was the So you've been evaluating BioCoat Gold for a couple of years on corn and beans. What was kind of your overall responses? What were the net responses that you came away with? What were the key insights that emerged from that?
Sure. I think one of the most important key insights is I'm not so sure personally I'm able to visually observe above ground differences in crop responses. I've been looking. I've been definitely looking because I would love to be able to see something visually that stands out. When as far as flying drones over the fields to look for separation, I'm looking at plant structure and leaf coloration. And maybe I'm just not looking for the right things. I certainly admit that. Maybe I'm not measuring the right things, but I just haven't been able to see visually above the ground where you see this robust colonization underground. And likewise, I think those who understand mycorrhiza realize that you can't dig up a root, turn it upside down, and see the mycorrhizal hyphae. They're microscopic in nature, and so we have to think outside the box for other ways to deploy measurement tools to determine whether or not we think we're making a difference with mycorrhizal colonization. I wish we had the ability to do so, and I know we can put things under a microscope and have closer looks there. But just stepping out into the field and observing with one's senses, I don't feel like we've got the attunement yet. And again, I admit that maybe I'm just missing it, something that could be obvious to observe the impacts that mycorrhiza have.
Yeah, well, it's in some ways, I think it would be very valuable for all of us to realize that in our crop scouting approach and our approach to agronomy in general. Um, because I feel that in many ways we have been misled by what I have sometimes called the deception of perception. We see something visual, like we see a plant turning dark green from a nitrogen application and getting lots of this vegetative growth, and we and the response is very rapid, very immediate. It's an immediate reaction, and in our minds we associate that with that as being good. We see this, and some cases it may be, but not in all cases. In some cases it's detrimental to have that flush of dark green growth and being overloaded with nitrogen. And so I think it's very valuable for us to develop an appreciation for the things that we can't visually see, and saying that sometimes these biological effects, obviously from an economics perspective, there needs to be an economics crop response. There needs to be improvements in overall ecosystem performance and function. There are different things that we may need to be measuring, but it might be wiser for us to recognize that maybe the responses that we're looking for are not visual.
I feel like those are powerful words, and certainly has been my experience as I'm observing crops and looking for other ways that I can measure these types of responses. And that's been a really interesting part of this journey, is that sometimes, as you mentioned, you can't always see the things visually or with your own human senses, and so it forced me to think outside the box. And what other ways can we measure these types of effects in the systems? I'm excited that we have tools at our disposal, things like PLFA and some of the other biological testing services that are now in the market. It's a really exciting time to be in this space as an agronomist who is now diving deep into soil biology, knowing full well that this is probably where the most lowest hanging fruit exist. To be empowered with measurement tools to better understand what's going on below the ground is just an incredible opportunity for me.
Yeah. Yeah. So, Joe, you shared the data with me of the various crop varieties and yield responses and crop responses that you had gotten, the ROI responses. And I shared that with our team at AEA, and I didn't personally know many of the varieties, but one of our agronomists pointed out that the varieties which tended to have the lowest yield response were also, I think this was specifically on corn, if I remember correctly, were also the shortest day varieties. Did that stand out to you at all? Am I remembering that correctly?
It certainly does. It stands out to me. And perhaps one could form a logical argument that inside of a shorter growing window, there might be more upside potential to utilizing these biological inoculants. I think also more the nuance in the data is that those were grown across a wide variety of soil types, growing environments, and other various types of contexts that may not manifest out of the data itself. But there were certainly a lot of variables that went into the various outcomes we saw there. As a whole, though, I'm encouraged by what we saw in two growing seasons that I've been doing this, where what I call bookend growing seasons. 2023 was the driest on record for us since 1988. In 2024 was the wettest on growing season on record for us. And so in these extreme type of environments, we still saw positive responses across two very, very opposite growing seasons. To cut straight to the punchline with the data, my numbers suggest that we're seeing about a 5 bushel response in corn, which I thought was quite encouraging. This data was statistically significant, and we saw wins 65 or more percent of the time. To me, that's a strong signal, I felt, based on the size of the plots that we did this in, the number of plots that we did this across. And likewise on soybeans, we're over 4 bushel response there as well. It wasn't quite statistically significant, but we had wins over 75% of the time. And so while I don't say we found a silver bullet per se, I think we've got enough of a signal there to say there might be something to this, and certainly encouraged me to keep pressing and keep looking.
Yeah, I just want to clarify on the data to make sure that I'm understanding and our audience is understanding correctly. When you say on the corn that you had a positive response 65% of the time, and then what was the yield response? 5 bushels?
Yes, that's correct.
So is that 5 bushel average, is that including the 35% that did not see a positive response? How is so that's across all data sets?
Yeah. So there were, in 35% of circumstances where there was not a positive yield response, where there would have been a couple bushel difference in between the control and the treated, that is absolutely built into that average. So that average represents across all circumstances, whether it won or not.
Yeah, got it. That's an important clarification, important point. Um, so what does this, going back to the point that I have just made repeatedly, and you mentioned at the beginning that seed treatments are one of the greatest ROI. We had one experience this year where a foliar produced the greatest ROI that I've ever seen. But speaking as categories, usually seed treatments are the greatest ROI treatment response that we see as a group. And you actually did the work to translate those numbers into an ROI response. What were the ROI ranges that you found?
Sure. I think if I remember correctly, a 5 bushel response is going to produce. Certainly, you're getting your money back for the cost of the product. There's no question about that.
Well, we need to do better than that, or we might as well go home.
I agree, and I think it should be baseline assumption. And if we're not 2 or 3xing, what are we even bothering with?
Right.
But my data suggests that we're well beyond 3x on corn, and I think we're pretty close on the beans as well. Which again was a strong enough signal to me to say that we should probably go back and continue to look at this because we're beyond just paying for the product itself. I think we're in the zone where you are significantly money ahead if you can replicate the 5 and 4 bushels on corn and beans respectively.
And we spoke a bit about day length on corn, and I'm curious about your perspective on what were the variables that you saw contributing on the soybeans. Were there any insights that emerged as some varieties responding better to others, or was anything that emerged there?
I don't feel like I've been able to extract anything that really stands out. I guess one thing that I'm aware of it, and I've seen this in the literature out there as well, is that there does seem to be variety and hybrid specific responses to colonization. And, that makes it really messy because now we got to drill down and identify if indeed there are certain hybrids or varieties that colonize or respond to this better. That's a real challenge because, anyone who's planting row crops, corn and beans, recognizes that you get 3 or 4 years out of a hybrid, unless it's a unicorn. Maybe it sticks around for 6 or 7 years before you cycle into new ones. Doing the research on that is really hard because they cycle so fast that you just don't get enough time to do the research and then ride the horse, so to speak, to get the most out of that before they cycle through hybrids. And so that's been a challenge that I think we're going to have to keep in mind as we move forward is if there is in fact hybrid and variety specific responses, how do we get those teased out as quickly as possible?
Is that something that would be possible to measure in the laboratory as you did that initial research, perhaps before we even need to go into the field?
Yep. And I think that would help solve that problem. If we could come up with a way to do some sort of relative comparison of inoculation and therefore colonization, that would be quite helpful.
Earlier in our conversation before the microphone was running, you and I had a conversation about day length on soybeans, and this has been a conversation that I'm really interested in. I've been really intrigued with Jason Mauch's work on his relay cropping, relaying wheat and soybeans. And if I remember correctly, he's planting soybeans, I want to say 4 weeks ahead of what is common in his area because he's able to get frost protection from the wheat overshadowing the beans once they emerge. And what I'm so impressed about Jason's overall system, of course, there's some variation from year to year, and he's constantly working to refine and improve and try new variations. But it's my understanding that he's getting 100% soybean yield and 80% wheat yield for an aggregated 180% yield of growing each of those crops separately. And I think part of the reason there's a number of contributing factors, but part of the reasons why he's able to get 100% soybean yield is because he's planting 4 weeks earlier. What have you been observing? You're a lot further north.
Yeah, great question. Foremost, I think Jason's work is just incredible. I love watching trailblazers break all the rules and go out there and mess things up, but come back with just amazing results. So my hat tip to Jason for all the work that he's doing in this space. My research has shown here north of the 45th parallel that absolutely getting beans in the ground early pays. That is irrefutable data at this point. My data here personally that I have collected over the years, as well as that out of the UW Wisconsin, has reinforced this concept that beans planted early pay back significantly to the tune of it's a half bushel a day throughout the month of May that you give up for each day that passes that you don't have beans in the ground. And so to take that step further, I have been interested in this concept regarding how do different maturities of soybeans respond at different planting dates, and whether or not we can quote unquote hack the system to grow a short relative maturity bean, get it harvested earlier, and then get covers in for those that choose to get covers established. And so a brief setup for you here to share what I've got for data. I've been collecting data from variety plots for the last 7 years across northern Wisconsin and northern Minnesota. And this database now extends to 9,000 data points of soybean weighed yield measures across a wide variety of relative maturities. And what my data has found is that an early maturing bean, and for us here up in northwest Wisconsin, I'd call that a 0.2 to a 0.9 relative maturity bean. That class of beans will yield right with what I call a full season bean, which for us is a 1.5 to 2.0 bean, if those are planted in the earliest opportunity we have. So for more context, where we're at in northwest Wisconsin, early planted beans for us is the last week in April, first week in May. What my data shows is that if you plant an early maturity bean in the first 2 weeks, last week in April, early week in May, we will yield right with the full maturity beans. Now, that early RM bean class, it falls off a cliff if we get into the second half of May, and those beans will significantly lag the full season beans. So I happen to put this caveat on there that if someone wants to take advantage of these early relative maturity beans, they got to go in the ground as soon as you can get them in there within reason. Of course, as you know, if the soil's fit, temperature's ready to go, moisture conditions, blah, blah, blah. However, doing so pays back significantly. You don't give up significant bushels based on the maturity of the bean. And if there is, to be 5 or 10 days of earlier harvest window, that's incredibly valuable to those of up here who are trying to establish cover crop late September, early October. And so that's been a really interesting observation I've made over the course of studying these things. For those of us trying to establish cereal rye or other types of cover crops following soybean, every day at the end of September matters so much. If we can trim back our soybean relative maturities without giving up yield, that buys us that time. And that's a have your cake and eat it too type situation.
Yeah. Yeah, that's a pretty broad data set. That establishes a lot of credibility for what you're describing. That's a very broad data set, and that's very valuable information. And it's so just so that I understand, I'm used to the people who are interested in planting cover crops. There's often a more regenerative or organic mindset that is associated with that, and often one of the concepts that's also associated with that pattern of thought is waiting to plant until you're planting into warmer soils.
Mm-hmm.
And so just to make sure that I understand clearly, what are optimal soil temperatures for planting beans if you're going into the ground in late April, early May in northern Wisconsin?
Yeah, great question. Good UW research has identified that soybeans will begin the germination process at 46 degrees. I find that stunning. I mean, that's cold. Nobody wants to do anything at 46 degrees, including the microbes. So I find it absolutely fascinating that soybeans are actually more tolerant of colder soils than corn is. The rule of thumb for corn's always been 48 to 50 degrees, but it's seemingly these soybeans can do 46. So I find that remarkable. And the major risk that I think soybean producers have this far north, if they're going to go put soybeans in the ground with the soils 46, 47, 48 degrees at the end of April, is that there is likely a good chance that we will experience a frost, most notably on Mother's Day, which the greenhouses have figured out, which is why they plant extra baskets, because so many of us have to go back to the store and buy replacement baskets after Mother's Day frost, right? Back to soybean growers. The concern is that if I plant my beans in the last week of April or first week of May and we experience a mid-May frost, am I going to be planting my beans again? And then why did I even bother? But my experience has shown is that these soybean varieties seemingly have antifreeze built into their plumbing. I watched a soybean field across the road from my house a couple of years back experience a 4-hour frost/freeze at 28 degrees as the cotyledons were unfurling in the field. They had just emerged and they're just opening their wings. Despite 4 hours or 5 hours of 28 degrees, that crop went on to produce a 60 bushel bean harvest. And so I think we have to give credit where credit is due, that these soybeans these days, these varieties have incredible resilience to extreme temperatures. And I think that's why we see this data continue to stack up, that if you can get them into the ground as early as your season allows with relative prudence, there is vast, significant upside to be captured.
That's fascinating. How long does that antifreeze effect last? You're mentioning at the cotyledon stage, but does that still hold true if you're at first trifoliate?
I would suspect not. I will also say, however, that I think it is rare for us up in this part of the world to have a situation where we would get beans to first trifoliate stage and then experience a frost. Certainly that possibility is there, but in our world up here in Northwest Wisconsin, those beans are slow growers for the first half of the month, and that first trifoliate is probably not going to emerge until after the threat has frost has diminished. Now, granted, I understand there's always that freak frost, the late May or early June that can pop up occasionally, in which case, yep, we're all kind of stuck in a pickle because everyone would have had their beans in the ground regardless. But for those that are willing to push the edges a little bit and get them in last week in April and May, I think that by the time they have put on that first trifoliate and the foliage thereafter, most of the frost threat has evaporated.
So, what are the possible downsides? What are the possible downsides of planting soybeans early?
Possible downside is going to be frost. I can't find another one beyond that. I really can't.
Hmm.
Some might argue that, well, you get those beans in the ground that early. For those that are using herbicides, those herbicides run out of gas, and now you have to think about a third pass on top of the two that you're already doing. I still don't think that that's a justifiable enough reason to not plant them early. However, just
Hmm.
because the data is so solid that when they get in the ground early, they yield more without question.
Yeah. Awesome. Thank you for that. This is intriguing information. This is certainly the first time that I'm hearing about what you're describing, and I suspect that the same is true for many other people as well. Um, we haven't yet talked about your sweet corn production, your pumpkin production, the pumpkins that you're selling. I've been having a lot of conversations with people over the last year, or really over the last 6 months. There's been more momentum on nutrient density testing and measuring and growing for nutrient density, actually growing for quality than there have been lots of people having conversations and there have been lots of anecdotes, but people are actually beginning to measure what they're doing and what's happening and what's going on. What are you working on?
Yeah, this has been really exciting part of the little regenerative operation here on our 3-acre hobby farm. We pride ourselves on sweet corn quality. And like what you had just mentioned in regards to how do we measure these things, I too have had an interest in measuring whether or not the produce that we make that is consumed by humans has superior quality. And so just on a whim, last year, I went out and harvested some of our ears of sweet corn. And then I went to the gas station and bought some of that chalky cardboard that they package as sweet corn. I sent these ears into a forage lab and had them analyzed for basic nutrient content as well as sugar content. And perhaps surprise to nobody, we found that the fresh picked, regeneratively grown sweet corn from our operation had significantly higher sugar levels. I think that's to be expected. But we also saw higher nutrient density in the sweet corn that we had produced as well, which was very satisfying to know that we're marketing a superior product, and now we can back that up with metrics on a lab report.
But when you were sending samples to a forage lab, did they measure the entire ear, including the cob itself, or did they measure just the grain kernels?
Great question. I suspect that they probably put the entire ear into a blender. It
Yeah,
did not specify to remove the cob from that and just
yeah,
measure the kernel. So that would be the entirety of the ear.
yeah. Well, you know, sweet corn is interesting in that it is one of the plants. It's true for many fruit. And the vegetable category is particularly true of sweet corn as well. That although you could argue that sweet corn is a grain, but that it's been selected and it's been bred for what you could almost call artificial sweetness, that you can have high sugar content in the ear itself, in the grain itself, when the rest of the plant has a very low Brix reading and very low sugar content, high degree of insects and disease susceptibility. So it's been selected to optimize for sugar in a particular plant location, and that sugar. There's a reason why our tongues are attracted to sugar because historically sugar used to be associated with mineral content. And the reality is today, um, with a lot of the breeding efforts, sugar should still be associated with mineral content, and sometimes it is. But what is more closely associated with mineral content and nutrient density is flavor and aroma rather than sugar content. So I'd be really interested. Well, no, I was about to say I'd be interested in knowing how the flavor compared, but we all know how the flavor compared with the with the gas station.
That's easy to answer. That's easy to answer.
Yeah. Yeah. So, what have we missed talking about? What are some? Is there any other highlights or any other conversations? You've been working and doing lots of different things, and you're very good at sharing information. This conversation has been very information dense, which I really enjoy. Is there anything that we've missed talking about?
Yeah, sure. One other thing I'm going to add on to this in regards to how we're managing our little hobby farm, there's a couple things that stand out to me that have been incredibly profound. Number one is that we grow pumpkins on a rye cover crop system. So I plant rye at the end of September for next year's pumpkin patch. I come back at Memorial Day, I roll or crimp that rye, and then we sink transplants into that rye mat. And I could not grow pumpkins without this system. I just absolutely couldn't do it anymore. Tillage and herbicides, can get you some of the way when growing pumpkins, but for those that do grow pumpkins, you recognize the challenges associated with that. There's no good herbicides that are labeled for weed control, and I don't want to use them anyways. Likewise, on the water side of things, we don't have irrigation here, and so when we get into a dry season like 2023, I'm relying on whatever Mother Nature can provide for moisture. Now, having incorporated the rye system for growing pumpkins, I've essentially check both of the weed control and the water situation off the list, because that rye mat does a fantastic job of suppressing weeds and holding moisture in the soil system, not to mention providing a very favorable and robust scenario for microbes to do their thing. And so in the last couple of years using this rye system, I've been doing it for going on 10 or 15 now, but the last 2 seasons we've had using this rye system have been our 2 most productive years growing pumpkins. And as I mentioned earlier in the podcast, we had both the driest as well as the wettest on record in recent memory. So I'm 100% sold that the system works, and it gets better every year by sticking to it.
How long have you been doing the rye mulch?
The rye mulch has been going on almost 15 years now.
Okay. And I think the discussion about drought management and this is an important one because um, it's generally recognized that having a rye mulch and the type of system you're describing is going to conserve water, but I don't think there's a full appreciation for the degree to which water conservation and conserving water and having the crop be very water efficient can actually happen. So you had in 23, you had the driest year on record since 88, which is saying something because in 88, and at least it was a widespread drought in our part of the country, trees dropped their leaves. Eastern hardwood forests dropped their leaves in 88. And so having that type of drought conditions, did you see any type of moisture stress on the pumpkins, which are not necessarily a low water requirement crop? They've got some pretty substantial water requirements.
Yeah, they showed all the signs of being thirsty. In a pumpkin plant, their leaves are going to flag droop when they're under moisture stress. And we certainly did see that in this system. However, I believe that if we hadn't had the rye mat there, we would have had total plant loss. So even though our plants were thirsty, we didn't lose them to drought, which I think we would have otherwise in a non-rye system. They went on to produce fruit. And again, we had one of our best harvests that we've ever experienced. 100% credit that to the rye mat, not only from a water holding and a weed suppressive standpoint, but we've also been able to measure in our soils just how biologically alive and robust they have become as a result of doing this for the last 10 or 15 years. Now, granted, it goes a lot more beyond just using the rye system. There's an entire rotation program that takes place here to set the system up for maximum soil health. But again, the rye plays a really instrumental role in that.
Yeah, tell us a little bit about that. What is the rotation that's leading up to the rye? That's the next place that I was going to go. If you have this biologically active soil, I mean, saying that you had one of the highest yielding crops ever in the 2023 drought is a pretty substantial statement.
Sure. So in our system, we have taken 2.5% organic matter that was an agriculturally farmed field conventionally for the last 100 years. And we've now bumped that up to 4.5% organic matter without significant off-farm carbon inputs. There's been a little bit of manure application every few years, but the carbon that's been put into the system to result in that organic matter increase has purely been from growing intensive covers at every single moment we can. So the rotation is set up across 3 acres with 3 different crops. Like I said, we grow sweet corn and we grow pumpkins. There is a 1 acre that is completely dedicated to simply building biomass. We don't monetize that acre, and I don't need to, because the benefits I get from growing sorghum Sudan through the summer, mowing it and incorporating that biomass back into the system justify the lack of revenue generation, which I will then pick up in the other 2 rotations. And so purely stumbled across this rotation by accident. Again, it's a blessing to have had figured this out, because I'm fully willing to take a full acre out of production just for the sake of building biology. And I think that's why we've been able to build this resilience into our system as a big piece of that.
So is your year in sorghum Sudan grass, is that ahead of corn, ahead of the sweet corn, or is that ahead of the pumpkins?
So that is going to be ahead of the pumpkins. Yep.
Okay.
The sorghum Sudan is sandwiched in between the sweet corn and the pumpkins.
Okay. Yeah.
And then, of course, every time we put cover crops into this rotation, there's always living roots out there. I'm inoculating these covers, small grain seeds with the rye and obviously the sorghum Sudan. They get inoculated with mycorrhizae as well. So it's probably significant overkill and at some degree of cost. But I'm not going to compromise on trying to establish as much robust biology below the ground surface as we possibly can.
Yeah. With your sorghum Sudan grass production and your the rye contributions to the cover crop, how are you thinking about the contributions of cover crops from a nutrient management perspective?
Yeah, great point. So I've done a fair amount of cover crop biomass testing, both here on my own little farm as well as for the farm that I consult for. And one thing that has been illuminated that I did not expect is how significant the amount of nutrient these cover crops are able to sequester, even at small growth stages. I've been out and been able to capture cover crop biomass tests on short rye. Our rye will get to 8 to 12 inches before it's terminated in front of a corn crop around here. And so I'll cover crop biomass test it at that growth stage. And in those cases, I am finding there is upwards of 30 pounds of nitrogen sequestered in 8-inch rye, which I did not expect whatsoever. Likewise, there's a significant amount of P and K that are also sequestered in these short stature rye cover crops. A lot of times farmers will look at that short stature crop and go, why did I even bother? What's the value of this out here? I go, whoa, wait a minute. There's an incredible amount of value here just based on the nutrient value of the cover crop biomass test.
How are you accounting for that contribution in your agronomic recommendations? Because one of the things that I'm intrigued by is that I've seen Rick Clark has shared in his presentations the incredible amount of nutritional value, the nutrient content that is in these in cover crop biomass, and how do we account for that in our agronomy recommendations? How much of that can we expect to be available to the crop in the current season? And particularly in the case of nitrogen, how much of that is retained in the soil versus how much is lost to the atmosphere?
That is truly $1 million question. Certainly something I spend a lot of time thinking about, because if we can find additional ways to credit nutrients back to these systems, it reduces the need for synthetic fertilizer, which is something I think we can all appreciate.
And not by a little bit either.
Correct. Yes. My experience has shown that, in this 8 to 12 inch tall rye, there could be upwards of 30 pounds of nitrogen sequestered into that. Now, how much of that gets cycled back into that corn crop, I think, is a function of a whole bunch of different variables that we can really not put a straight assumption on. But some recent data that came out of iState that I just listened to this week showed that upwards of 14% of that is immediately plant available throughout the growing season. There's another significant proportion of that remains in an organic form that just hasn't decomposed or mineralized to the extent that we can credit that back. So that's one study from one university. I'm guessing there's other data out there that would suggest there's even more of that potentially available. And I think this is an area that needs significant focus, because if we can figure out how to grab those nutrients, that's a big deal.
Well, actually, I'm surprised that the number is as low as 14% if you're talking about, 14% if you're talking about a rye crop that is crimped when it's head high. That's one thing, because in some contexts, you have slower decomposition. But when you have a shorter rye crop that's 8 to 10 inches tall, even if you just terminate that and you leave it on the soil surface, that evaporates in a matter of a month. It's gone.
Correct. Yeah. C to N ratio on that short statured cereal rye is typically going to run well below the 20 to 24 C to N ratio that I think we all agree is what then directs that it is mineralized. Agree with you that 14% number out of iState seems on a little bit on the low side. But again, that's one set of data that I think that needs to be looked at closer, because anybody who's walked out into a field that's biologically active and you notice that stuff melts back into the soil surface over the course of a growing season has to wonder, there's a lot more nutrient being cycled there than anyone's taking credit for.
Yeah, absolutely. I've seen cover crop mats that were, in one of the fields that I walked on Rick Clark's farm here a year or so ago. We had at the beginning when he crimped the cover crop combination, there was an 8-inch thick solid mat, 8-inch thick solid mat, and that was of course when it was green before it had dried down. I'm sure when it dried down, it wasn't quite that thick, but still had to be 4 to 6 inches. And a matter of 3 months later, or even 2 months later, that's 80% gone.
Yeah.
So that's significant nutrient contribution, which makes you think, like, we're having this conversation about cover crops, but what about crop residue itself? What about corn residue? What about soybean residue?
Yeah, great question. I've had the same question about soybean residue. And in order to help get maybe a little bit of insight there, I went out and I did a cover crop biomass test on soybeans at the R6.5 growth stage. So R6.5, for those who may not be aware, is the equivalent of black layer in corn, where the soybean plant has now stopped translocating nutrient from the above ground biomass into the grain itself. I plucked all the pods off of that biomass sample and sent just the leaves and stems into the lab to be analyzed. So no grain, no pods. Probably should have included the pods, but Joe doesn't have an intern yet, so maybe next year. Either way, the results came back and I was absolutely stunned. It had showed that there was 130 pounds of nitrogen in the above ground biomass of soybean stover that goes through every farmer's combine. And these fields yielded 54 bushel and 45 bushel respectively. So if you're pushing over 60 bushel yields, there's probably more above ground biomass, in which case that nitrogen number gets even bigger yet. So I was stunned by that. I was stunned to learn that there's 130 pounds of nitrogen in the residue going through the back of a combine. And if you ask most of the land-grant universities what a soybean rotational credit is, many are going to say that it's likely not due to mineralized nitrogen left in the biomass as a result of that soybean residue, but it is in fact due to the absence of a corn-on-corn penalty, which we all know if you're growing corn on corn, it takes a little more nitrogen to grow that corn. Don't argue that point at all. But that tacit admission is that there is no mineralized nitrogen to be gained from soybean residue. But here we have this 130-pound signal coming out of the back of a combine. I was able to measure, how do you reconcile that? Well, fast forward to the 24 spring, I drove past a cornfield. And if you recall from earlier, I said that we had the wettest growing season on record. And so driving past this V4, V5 cornfield, I noticed that there were these odd diagonal stripes that were going across this cornfield. So I stopped, I put the drone up, and I was able to look at this from a field overview perspective. These diagonal stripes were obviously where the combine had harvested last year's soybeans at an angle. And where the corn was a darker green inside these concentrated bands happened to coincide where the residue was windrowed from the combine. And so I asked the question is, why does corn usually darker green relative to corn that's not darker green? And many probably would answer, well, it's because there's more nitrogen there. And then I say, well, that also happened to line up with where the soybean residue was windrowed out of the back of the combine. And so, what do we have going on here? Is there, in fact, nitrogen being mineralized out of the soybean residue that is contributing to the nitrogen pool for the following year corn? Seems to be the case. And I'd love to see more research on this to help reconcile this, how much nitrogen is, in fact, coming out of mineralized soybean residue.
Yeah, I think there's something here for us to dig into and understand a lot better, because one of the pieces that I've been intrigued by, based on what I've been learning from Christine Jones and just coupling that with a lot of historical field experience, thinking back with a lot of the experiences that I've had, I'm persuaded that the nitrogen coming from legumes has as negative effect on soil biology and bioavailable carbon and soil aggregation as nitrogen from fertilizer. I don't think there's a difference from the microbial community perspective. And some of the most compacted soils that I've ever seen were alfalfa fields, and they're closely followed by soybean fields. There are some very compacted soils. And I always just assumed that, or I gave credit to the field traffic that the alfalfa fields got. And I'm certainly think that's a major contributing factor. I'm not discounting that, but I'm coming to the conclusion that it's not just the traffic alone. It's the fact that we have a monoculture legume that is constantly fixing nitrogen, and that is leading to the collapse of soil aggregate structure. And soybeans, I think, are contributing the same thing. So now, if you think about 130 pounds of nitrogen coming from soybean residue coming out the back of the combine, the question is, how much of that remains in soil for the following year's crop? How much of that is lost to the atmosphere, particularly in soils that have less biological activity? We know that soils that are more biologically active, essentially the faster that is decomposed, the faster that is digested, the more of it you capture in the soil versus losing it. Lots of interesting things to explore there.
Yeah, absolutely. I agree. These are the right questions to being asked. We have a unique environment up here in Northwest Wisconsin where soybean harvest is often followed by quickly freezing. We might get some rain between soybean harvest and when the frost does hit, but when we freeze, we suspend all these processes, correct? And then we move forward in the calendar in a frozen state of animation. We start to thaw out late March, early April, and we kind of resume those microbial processes. And then we come back, we plant corn late April, early May again. And so all of the processes that take nitrogen away from the system, whether it be microbes, turning it into nitrogen gas, or the leaching process or denitrification, all the things that take nitrogen away tend to be somewhat minimized just due to how far north we are and the fact that we push this pause button on there. And so I think it tees up the opportunity to think outside the box and maybe ask some more tough questions in regards to what actually happens to this residue, especially in a system where we know we push the pause button for a significant duration of the time that is laying on the soil surface. Just it tees up a lot of really interesting questions.
My goodness, Joe, this has been a lot of fascinating information. Thank you so much for being willing to share your experience and the work that you've been doing. I think it deserves to be much more widely known. What is a good way for people to connect with you?
Sure. It's been a real pleasure, John. Thank you for that. The easiest way people can find me, I'm fairly active on Facebook under Ailts Agronomy. That's AILTS Agronomy. And that's typically where I post a lot of the work that we're doing here on the farm as well as in my agronomy business.
Thank you for being here. Thank you for sharing your work.
My pleasure. Have a great day.
The team at AEA and I are dedicated to bringing this show to you because we believe that knowledge and information is the foundation of successful regenerative systems. At AEA, we believe that growing better quality food and making more money from your crops is possible. And since 2006, we've worked with leading professional growers to help them do just that. At AEA, we don't guess, we test, we analyze, and we provide recommendations based on scientific data, knowledge, and experience. We've developed products that are uniquely positioned to help growers make more money with regenerative agriculture. If you are a professional grower who believes in testing instead of guessing, someone who believes in a better, more regenerative way to grow, visit advancingecoag.com and contact us to see if AEA is right for you.